Hi, what we're gonna talk today is about displacement, velocity, and acceleration. This video is created by Erdem Benjamin 1208. Okay, first let's start with a displacement. Displacement is defined as the change in position of an object which has delta x equal xf minus xi as an equation. Xf refers to the final position and xi refers to initial position. Okay, first let's start with a displacement. Displacement is defined as the change in position of an object which has delta x equal xf minus xi as an equation. Xf refers to the final position and xi refers to initial position. Displacement time graph. Slope equals velocity. The y-intercept equals the initial displacement. When two curves coincide, the two objects have the same displacement at the time. Extrema, highest and lowest point in the graph, which can be separated into two types. First is global point, which are global maximum, the highest value in the function, and global minimum, the lowest value in the function. Second is the local point. Any other points which are not the global point is called local points. Velocity. It's defined as the derivative of the position function. Velocity time graph. It gives the velocity in the aspect of time. Straight lines imply constant velocity. Curved line implying acceleration. If the line is flat and horizontal, the object is traveling at a constant speed because on every point in time the velocity is still the same. The graph with a steep slope experiences the fastest change in velocity. That object has the greatest acceleration. The average velocity of any object is the slope of the straight line connecting the endpoints of the curve, which can be found by instantaneous velocity. It is the slope of the line tangent to a curve at any point on a velocity time graph. Slope equals acceleration. The y-intercept equals the initial velocity. Critical point is the point of change in velocity, and the velocity at that point will be equal to zero. It could be the highest or lowest point. First derivative test. Growing or decreasing intervals of function at stationary points. If f prime more than 0, function is growing. If f prime is less than 0, function is decreasing. And if f prime equal to 0, function has a minimum or maximum. The acceleration of the object is the second derivative of the position function. It is the rate of change of velocity with time. The acceleration can be found by finding the difference between initial and final velocity divided by difference of time. Slope change means constant change in acceleration. The y-intercept equals the initial acceleration. Since velocity is a speed and a direction, there are only two ways for you to accelerate, which are change your speed and change your direction, or maybe you can change both of them. Graph acceleration. If the value of a is positive, it's gonna be a cable between accelerator. If the value of a is negative, it's gonna be a tail down, which means accelerate down. And if a value is equal to 0, that point is gonna be the point of inflection. Point of inflection. It's a point of a curve at which a change in direction of a curvature occurs. Can be found by using a function equates to 0. Second derivative test. It is easiest way to identify local maximum and minimum points, but sometimes the test is gonna be fail or harder than the first derivative test. Relative minimum and maximum. As we know that the x value is the highest or lowest point, but it's still not proved yet that where the point is. So the function for this example is going to be x cubed minus 3x, and the first thing that we have to do is to find the critical value. Critical point, as we know, are the point where velocity is point is relative means because the graph is concaving upward, while x equals -1 result in -6, which means that the critical point is relative max because the graph is concaving downward. The third question is to find out the interval. We know that the critical point is going to be where the slope change, so we create an interval as follows: -infinity to -1, and -1 to 1, and 1 to infinity. Then we choose a number in each of interval and plug into the velocity equation. If the result is positive, then the graph is increasing, and if the result is negative, the graph is decreasing. The fourth question asks for point of inflection, so we have to use the acceleration question. Then we solve for x, which is 1 and -1. The result will show x coordinate where the point of inflection lies, which is x equals 0. The last question is to find out which interval is the place where the graph is concaving up or down by using -infinity to 0 and 0 to infinity. Then we choose a number in each of the intervals and plug into acceleration equation.